Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about reaction of acetal. Okay, so the question is in front of you and you have to say what is the major product of this reaction. And here 4 options are provided and one of them is the right answer. I request you student, please pause the video, read the question carefully, and whatever answer you get, please write in the comment box along with few words as explanation. And don't worry about your answer will be right or wrong, because self-evaluation is essential for improvement. I believe you have tried by yourself, so it's my turn to give you the right answer. So as usual student, I suggest you first read the problem very much carefully. What is given? So this is student actually an acetal. This is allylic alcohol. Okay, and the other one is an acid, means it releases H plus, and reflux means heating. Okay, so what is the product? So if you look at this acetal and acid, we know acetals are stable in alkali, but they are not stable in acid. I have already discussed dedicated lecture on it. Now simple acetal will break down, or what can happen, acetal exchange, because acid is there, alcohol, another alcohol is there, and acetal is there, so that's also possible. So let's see what happens. So in presence of acid, what happens? This oxygen is student a very, means it's a hard base, proton is hard acid, so they both can react and produce this protonated species. Remember, when OMe is protonated, it becomes a relatively better leaving group, because the leaving group finally is neutral one. So what happened? This lone pair will push here, it will leave. Fine. So it will generate we may consider cationic aldehyde, and this is student a very good electrophile. Why? Because generally we know carbonyl group are electrophilic because of this electronegativity difference. So if this carbonyl is converted into a cationic species, so electron deficiency increases further. Actually the same thing happens in this case also. Okay, so it became a very good electrophile. Consequently, the alcohol or allyl alcohol present is in the reaction medium can act as nucleophile, it can open up. So in this way you may see it's a mixed acetal. So this part is may consider mixed acetal is formed. Now in the next stage, what you can expect? Still the medium is acidic, and see there is, if these oxygen got protonated, it will go back to the previous. Fine. But if the other oxygen is protonated, then another reaction possible. What do I mean? So this lone pair, one, it can push and it can leave. So ultimately at the beginning, what you can expect? That CH3, this is double bond O, this is CH3, and here this is the double bond. Okay, but here the oxygen is carrying a positive charge. Now just try to visualize a electronegative atom is carrying positive charge, is not that much stable. So consequently what happened? One proton from this will be abstracted and this charge will be neutralized, and in this way it will produce this. Means one part you can consider that this part is vinyl alcohol ether, and other part is student allyl alcohol. So allyl vinyl ether derivative is produced. And just recall that propionic acid is refluxed, means heating, and remember propionic acid's boiling point is close to 140 degrees centigrade. So you are actually heating the reaction mixture near about 150 degrees centigrade. It's a pretty high reaction temperature, student. So under this, means drastic vigorous condition, you may consider that Claisen rearrangement occur. More accurately, if I say aliphatic Claisen rearrangement. So what will happen? So it will push this, it will come this, and it will come here. So in this way, so one carbonyl and one alkene. And if you look at student, previously there was 2 carbon-carbon double bond, and right now here 1 carbon-carbon double bond and 1 is carbon-oxygen, and we know this carbon-oxygen is relatively more stable. Okay, this carbon-oxygen also overall stability is gained, so you may consider that is the driving force for this reaction. So what is the product? So under this reaction condition, this carbonyl double bond is the product. Now if this question is asked in your exam less than 30 seconds, how can you solve? First of all, you need to understand that this is actually an acetal and this is alcohol, this is acid. So in how this butadiene could be produced? So this water eliminated from this allyl alcohol. But remember student, for water elimination, first dehydration, carbocation generation, because acidic medium. After that butadiene is not that much easier, and acetal is more sensitive to acid compared to allyl alcohol. So this path is not possible. Option. And if you look at option D, cyclization, means this double bond is acting as a nucleophile. Simple, this is actually an isolated double bond, not possible. Otherwise cyclization overall not possible. Option gone. Now confusion is either option B or option C. So for that purpose you need to understand that student, this CH3CHOMe, it's an acetal, so in presence of acid it will break and alcohol can attack. So in the carbon chain, in the actually it's a simple chain molecule, it's an open chain compound, and there should be an ether linkage, because here the lone pair of oxygen is going to attack this carbon after this one molecule of methanol removal. So it should be ether derivative. So this is the product. But I repeat, but refluxing condition is given. So what will happen? Instantly through aliphatic Claisen rearrangement it will convert into this one. That's why this question is little tricky, although first 2 options are wrong option, very poor choice of option, but this is the difficulty. So you should learn this thing, that in case of these vinyl allyl ethers, under heating or reflux undergoes Claisen, this Claisen rearrangement spontaneously to produce this carbonyl alkene derivative. Okay, so this is the overall discussion, and in conclusion what you have learned today, that acetals are protected form of aldehyde and it is stable in base but not in acid, and that's why acetal deprotection under acidic medium possible, and it goes through oxonium ion as intermediate. And oxonium ion is actually electron deficient, and that's why it can undergo nucleophilic addition. But remember, because of oxonium ion formation, every atom got 8 electron filled, because carbocation is actually 6 electron species, but because of this conjugation that electron deficiency is somehow neutralized. Now allylic enol ether, this aliphatic version can also undergo Claisen rearrangement in presence of heat, and here heating is mentioned to you by the term reflux, because if you consider that refluxing means heating a reaction mixture at its boiling point, or some excess amount of heat need to provide such that it can boil and that's some excess with respect to the boiling point of the solvent. And if you look at the propionic acid, it exactly boils at 141.2 degrees centigrade. So plus 10, 15 or plus 10 to 20 degrees centigrade extra need to given such that refluxing became possible. So under this much heating condition the reaction is going on, and that's why this Claisen rearrangement is possible. And the final point is that Claisen rearrangement is actually a 3-3 sigmatropic rearrangement. So this is the end of discussion. Thanks for watching. I believe this video may be useful for you. Please write your opinion in the comment box, and if you really consider the content of this channel is worthy, then please help this channel to grow, and if possible please visit my another YouTube channel.